Hello everyone, my name is Shanhe, and my topic is buffer overflow weakness. What is a buffer overflow? It's a common software coding mistake that attackers can exploit to gain access to user systems. A buffer overflow, or we say a buffer overrun, it happens when more data is put into a fixed length buffers than the buffer can handle. Right. Also, such attack is also depends on the language used to writing the vulnerable programs. For example, the code writing in JavaScript or some other front-end language, they have built-in protections, so they are not susceptible to buffer overflow. However, a buffer overflow in a program writing in C or C++ or assembly language can allow the attacker to fully compromise to the target system. Executing buffer overflow attack. Let's start from an attacker perspective. Those attackers exploit the buffer overflow problem to alert execution paths of the applications by overwriting part of its memory, right? So the malicious actual data they put in that might contains in the code designing stage or implementation stage to trigger the specific actions that give them interest. That is where the system crash or denial of service. And here is buffer overflow attack examples. The coding errors are typical the cause of the buffer overflows. On the left side, the simple C language programs. If you are familiar with C programming, pause the video, think about programs. There is a possibility of buffer overflows in these programs because the get function does not check the array's boundaries. So on the right side is the example of this code. What attackers can do is this coding mistake. The program gives users root privilege, right? Even though the users enter incorrect password. In this case, attackers supply the input with a length greater than the buffers can hold, creating the buffer overflows, which overload the memories of the integer path. Therefore, even the incorrect password, the value passed become non-zero, and attackers receive the root privilege. Next is buffer overflow causes. What causes buffer overflows? We know the coding errors are typically the cause of a buffer overflows, right? And also common application development mistake that can lead to buffer overflows, including the failing to allocate large enough buffers and neglecting to check for buffer overflow problems. And these mistakes are typical problematic with C and C++ language, so which does not have built-in protections against the buffer overflows. Consequently, the programs written in C or C++ are often targets of buffer overflow attacks. Next is buffer overflow potential mitigations. So I separate the mitigations in different phases of development. The first phase is requirements. Negotiates with the users, and the developer can decide which language they use for development. So that will reduce the probabilities of generating buffer overflow weakness. The second phase is architecture and design. The developers can use vented libraries or framework that does not allow this weakness to happen or provide construct that make the weakness easier to avoid. The third one is implementation phase. Consider to following the rules, when allocating and managing the application's memories. So first, double check your buffer is as large as you specified. Second, when using functions that accept a number of bytes to copy it, be aware that if the destination's buffer size is equal to the source buffer size. And third, check buffer boundaries if necessary the buffer in the loop. And lastly, if necessary, truncate all input strings to a reasonable length. before passing them to the function. Last phase is operations. Run or compile the software using features or extensions that randomly arrange the positions of a program executable and elaborate in its memory. Next, buffer overflow CWE. When working on the research in the CWE about buffer overflows, I find there's a list of CWEs that indicate different types of buffer overflow vulnerabilities. It's very interesting to see, like the typical one is CWE 120 we are talking about. It's classic buffer overflow. And there's some other type like CWE 121, stack-based buffer overflow, heap-based buffer overflows. And I find out there's really interesting some others CWEs like CWEs 190, integers overflows or wraparounds that can potentially trigger buffer overflows. And usually each vulnerabilities has a relationship with other vulnerabilities. Their relationship like a parent-child, peer-to-peers. So the function interest is really complicated in every program. So every single function that might have potentially triggers other programs to become the buffer overflows or other vulnerabilities. Next, buffer overflow CVE example. The first one is CVE 2003-0095. Vulnerability type is SQL code overflowed. This vulnerability is found in the huge company called Oracle, and they product Oracle database server in versions 8 and 9. This vulnerability allows remote attackers to execute arbitrary code through long username. Even huge company developers make the common mistake, right? And the severity score is 10 since they post the CVEs, which means they already fixed the issues. And here's another CVE's real-life example, CVE ID 2004-1327. The vulnerability type is also SQL code overflowed. And the buffer overflows in this product named Crystal FTP clients version 2.8. This vulnerabilities, allows attackers execute arbitrary code through the response to a list comments that contain a file's names with long extensions. So basically, it's like the pictures found in their bug fixing documentation shows below, the attackers can take over user privilege to run the FTP client side just by typing too many A's, and the code will take over the privilege from the users. And the severity score of this is 7.5. This is my presentation. Here's the reference.